In this video, we're going to compare the graphs of quadratic functions, and the question we're asked is which statement about the quadratic functions below is false. So before we get going any further, I want to highlight that word false. It's very important because sometimes it's going to say which following is true, sometimes it's going to say false, and I feel like sometimes they're trying to trick you with that statement. So anytime you see true or false, make sure you highlight that or underline it so you know what the question's asking. All right, we have three equations, and we're going to type those equations in our y equals screen. I know it says f of x, but we can treat f of x as if it just says y equals. G of x, y equals. H of x, y equals. And then we can get our calculators out and start typing out those equations. So, first equation, y equals negative 2x to the power of 2. Get out of the exponent, plus 4. Second one is 1/2. To do a fraction, I'm going to open a set of parentheses. So open parentheses, 1 divided by, to get the fraction I hit divide by, 2, close my parentheses, x to the power of 2. And then get out of the exponent, subtract 5. And for the last equation, we're going to do parentheses, negative 3 divided by 4 to make negative 3/4. X to the power of 2, let's get out of that exponent, subtract 1. Now that we've typed out all the equations, I'm going to show you a trick. Press the left arrow key and keep on pressing it until you get on top of that little line that's next to the y3. And we're going to make that a different shading than the other two lines. So I'm going to press enter on top of that line to make it darker. Let's go up to the other one. I'm going to press enter on this line, keep on pressing enter until it makes a dashed line. Alright, this one is dashed now, so the first line is now solid but thin, second line dashed, third line thick. We're going to hit graph, and it should graph all three lines and make them all three look somewhat different. So there's our thin solid, our dashed, and then our thicker line or thicker parabola. Now that we've graphed all three of them, we can compare them with the statements that were given. So the first statement says the graphs of all of these functions have the same axis of symmetry. In other words, all of them should be split in half by the same line. And if we look at all the graphs, we notice all of them are split exactly in half by the y-axis. So they all do have the same axis of symmetry. So that one's true. Remember, we're trying to find the one that's false. All right, the next statement says the graphs of exactly 1 does not cross the x-axis. Okay, let's grab our calculator and let's see if one of those graphs does not cross the x-axis. We notice the dashed line crosses the x-axis. If we look at the thin solid line, it crosses the x-axis, and then if we look at the thicker line, it does not cross the x-axis. So that's true. Exactly one of the graphs does not cross the x-axis, so that's true. Next one says the graph of all of these functions have different y-intercepts. So looking at the graphs, the thin solid line crosses up here, the thicker one right here, and the dashed or dotted line right here. So they all cross at different spots. So that statement is also true. The last statement says that the graph of one of these functions have or has a maximum point. So let's look at our calculator, and if we look at it, you'll notice that two of the functions have a maximum point, not just one. So our answer is D. Now that could be a little bit ambiguous. They could have stated that a little bit better by saying exactly. In this case, they're not trying to trick you. They just want you to recognize that that two of the graphs have maximum points instead of just one. There you go. I'm about to give you a problem to try on your own. When you see it, please press pause, work it out, and press play when you're ready to see the answer. So here's the problem for you to try. Go ahead and pause the video, work it out, and press play when you're ready to see the answer. Okay, I went ahead and typed out all of the equations. One thing I'd like you to notice that the top equation you should have hit subtract for instead of a -4, so subtract above the plus button. Also notice that I put both fractions in parentheses and that I used a negative in front of the 2/5. So the negative is that button that is below the 3. Now that we've typed them all in, we can hit graph and you'll see the graph of all the three functions, so we can go ahead and compare them. Note that on this question it says which of the following is true. So we're looking for the true statement this time instead of the false statement. First question or first answer choice says the graph of all these functions have the same axis of symmetry. So if we hit graph, we'll notice that not all of them are split in half by the same vertical line. Two of them are, but this function that is graphed, that's the thin solid line, does not have the same axis of symmetry as the other two. So the first one is false, which means it is not true, so it's not the one we want. B, the graph of all of these functions have the same x-intercepts. So we go to our graph, and you'll notice that not all of them cross the x-axis at the same place. Some cross over here, some right here. So no, that is also not true. The next one says exactly one of these functions has a maximum point. So we go to our graph and we'll notice that exactly one of them does have a maximum point. That dotted one has a maximum, the other two have minimums for their vertices or vertexes. So that's true. It looks like that's our answer choice. Let's go ahead and check D to make sure. The graph of two of these functions have the same y-intercept. So we go to our graph and we'll notice that none of the graphs cross the y-axis at the exact same place. So this is not the correct answer either, and C must be our answer.